so I was kind of inspired by that, I guess. And then for the hackathon, I needed an ETH-related project, and that wasn't implemented yet, so I thought it would be a good idea to start that. So that's kind of how it happened.
Well, awesome, great work, and the fact that you and other people also, but the fact that you guys whipped that up in a hackathon is very admirable and just amazing work. And so I know you're here to present, so I'll let you get to that, and I'm excited to see what you have in store. So yeah, the floor is yours.
Cool. Okay. Thanks, Jimmy.
Thanks,
Cool.
Jimmy.
Hello, everyone. So I'm gonna share my presentation to start off. So yeah, I'm just gonna start with. I think can everyone see this? I'm gonna make it bigger.
That's what she said.
Cool. So yeah, I guess to start off. So yeah, I'm gonna start off with just a little intro about Dawsomer and yeah, kind of where it's at, like how it relates to Polkadot and that kind of thing, and then I'll go into a bit of a demo, so showing syncing Polkadot and Dawsomer and as well using the front end. So yeah, cool. So just to start off, so I'm Elizabeth. Yeah, I've been working at ChainSafe for almost 4 years now, working on various projects in my time. So I've been working on Dawsomer for almost 3 years, I think. So since the beginning, so I'm quite familiar with it. And yeah, just currently working on all the different protocol implementations we have.
Damn, Matic.
So yeah, so just to start, what is Dawsomer exactly? So I don't know if there's been any Polkadot presentations thus far, so I'll just give a quick kind of Polkadot overview. So it's one from Moon. Okay, cool. Well, I'll make it quicker then. So Polkadot is just an L0 kind of interoperability protocol. So you have like a relay chain, and then you have parachains that all have independent runtimes, and then they all connect to each other via the relay chain and participate in shared security. So yeah, it's kind of a nice way to have chain interop and all have shared security and cross-chain message passing and all that kind of nice stuff you want. So what is Dawsomer? So it's a Go implementation of the Polkadot host. So the Polkadot host is essentially all the stuff that a Polkadot node needs to run that isn't the runtime. So what's kind of special about Polkadot is that it has a runtime, which is like the state transition logic, which is just a Wasm binary. So this can easily be swapped out. And also, yeah, so the Substrate blockchain framework, which Polkadot is built with, really showcases this. So with Substrate, you can easily build your own blockchain just by plugging in a runtime. So yeah, so Dawsomer is essentially analogous to Substrate in that regard, in that you can just plug in a Wasm binary runtime and kind of just run your chain. And as well, yeah, it's compatible with Polkadot, so you can use it to run a Polkadot node, or in the future build a Polkadot compatible parachain. So yeah, so the two main kind of functions of the Polkadot host are for importing a runtime and easily launch a chain with custom logic, and then the second is just creating a Polkadot compatible chain that might potentially become a parachain one day if you want. So yeah, so the current status of Dawsomer is that we can act as a Polkadot Dawsomer full node, so we can sync the entire network. Yeah, it's cool. And then also we're compatible with existing tooling such as Polkadot.js and the Polkadot telemetry site. And then we're currently related to our future plan. So our future plan is to interoperate with Polkadot as an authority node or validator node, so not just as a syncing node. So this will allow people to stake using Dawsomer and to get rewards and build blocks, participate in finality, and all that kind of good stuff that a real node can do. So So yeah, so currently we're running an internal Dawsomer DevNet with Dawsomer only nodes, and then trying to fix all the bugs there and get that nice and stable. And then after that, we're gonna move to the cross-client DevNet. So this will be Dawsomer and Substrate together to test the authority functionality. And then after that, we'll hopefully be able to go on the West End testnet, and then eventually Kusama, and then eventually Polkadot. So yeah, that's kind of our roadmap there. Cool. And then a little aside, so the Polkadot host can't become a parachain on its own. You use it to make a standalone chain, but it doesn't act as a parachain, as the parachains require some additional functionality that will connect the parachain to the relay chain.
Hi.
So in Rust, this is implemented with
Come up here.
Charity's Cumulus project, which kind of wraps Substrate and allows the Substrate node to become a parachain. So
Hello.
So Chainsafe has received a grant from the Web3 Foundation to build Go Cumulus. So this will be a Go implementation of Cumulus.
Oh.
So this will allow Dawsomer chains to become parachains essentially. So yeah, you'll be able to in the future build fully fledged parachains with Dawsomer. And as well, if you have a parachain and you want some alternative clients, you could use Dawsomer and Go Cumulus to have another client on your parachain. So yeah, so kind of higher level product goals for Dawsomer. One of our main ones is just becoming a modular blockchain framework that's really on par with Substrate. So yeah, so right now we're a Polkadot host, so we have all the functionality, I suppose, like in terms of like consensus and networking, the database, tree, etc. But we really want to make it super modular, so that's really easy to swap out the consensus layer, for example, which I believe Moonbeam has done. I think I got that correct. And then as well, being able to easily swap out things like a tree implementation or a database, and just like making it really well documented and easy for people to really use it as a framework. And then as well as just to increase client diversity in the Polkadot ecosystem. So yeah, so essentially alternative clients that we want more than just one client running on the ecosystem for both like the relay chain and parachains. So yeah, that's kind of where Dawsomer comes in. Okay, cool. So I will move to the demo section of the code, or of the workshop, of the presentation. Sorry. So let me share and unshare. I don't know how this is gonna work. I don't want to share my browser. Okay.
Why? What do you got on your browser?
There's some recursion happening, so I'm just gonna get rid of this for now, and if there's some issue, just like give me unmute and tell me, please. Cool. Okay. So I'm gonna make this bigger. So
That's
yeah,
what
so
she
the first
said.
thing I'm gonna show is just running a Polkadot or Kusama full node. So I'm just gonna go to the Dawsomer repo. Make sure I'm on the development branch. I'm up to date. Okay, so I'm just gonna build Dawsomer again. And then yeah, then this places the Dawsomer in the bin folder. So running a Polkadot or Kusama full node is pretty straightforward. You can just start it with the -- chain Kusama or Polkadot flag. So I'm just gonna show that to start. So yeah, I'm just gonna run a Polkadot node. Like I was already syncing this before, so it's gonna start not at Genesis. But if you run it for the first time, it'll start at Genesis. So yeah, you should see that it starts syncing shortly. So right now there's no peers yet, but it should start to grab some peers. Okay, here we go. So we have 10 peers now, and then sometimes it takes like a few seconds or a minute or so to start syncing. We should see that happening shortly. Okay, cool. So I'm on telemetry now. So you can see at the top, this is my node strategy fitness. yeah, the location, Dawsomer, the version of Dawsomer is running, the current peer count, so 16, that should be 18 now. The highest block on the chain, and the hash, and then this is the highest finalized, I believe. Yes, the highest block, highest finalized. So I'll give it a second for it to start syncing. It's taking a bit longer than usual this time, but just start shortly. Sometimes it waits till it gets like a lot more peers to start. So yeah, let's see how this goes. Give it a minute there. Okay, it's taking a bit longer than usual. Normally it takes not this long to start. I don't know if I should have restarted or something, but alright. Oh, okay, there we go. Okay, I think it's starting. Just, yeah. Okay, cool, yeah, it's starting. Okay, cool. I don't know why it was so slow. Maybe I have like other weird stuff happening on here. Yeah. So yeah, so slowly you'll see the block number creep up. Hopefully soon the finalized block will creep up as well. Yeah. I'll let it hang out for a while because I feel like maybe it's like around this. It's doing some heavy lifting, I think. That's why it's so slow. As long as that happens. Okay, I'll show Kusama now. Let's see. Is Dawsomer. So for Kusama, it's the same kind of idea. Just run it with chain Kusama. And then let's go to telemetry. Okay, here we go. So it just showed up as well. So Rule Castle. So yeah, same kind of idea. You can see the head of the chain, the finalize, that kind of thing. Okay, I don't know why this is so slow. I'm gonna reinitialize it and start again. But I feel like I have to change the little. There's some sections that are heftier to sync than others. Cool. So let's give these a bit of time. Whoops. If I'm the node. What is this called?
Oh, sorry.
Okay, here we go. Alright, so maybe this will start something shortly. Whatever, I'll just leave them for now. Cool, okay. So, running a Dawsomer development node. So I'm gonna show running Dawsomer dev node and then just what's it called? Running the Substrate front end to interact with it. I'm gonna put these away for now. So okay, so to run the dev node, you just run it with chain dev. I'm gonna reinitialize it because I was running it before. So the dev node essentially is a node that's configured to have just one node running on the network, and this one node will build a block every slot and also just finalize blocks as well. So it's such as like a standalone node that you can run. Oh, sorry. So we started with the WebSockets port for our front end. Okay. So yeah, so you just run it with the WebSockets enabled and still allows the front end to connect. So yeah, so cool. So the Substrate front end. So let me go to docs. show you front end template. So I already built it. I put the instructions here, but I'm not gonna rebuild it. I already built it. So I'm just gonna start it. Oh my god, what happened here? Oh, I think it's the node version. Okay. Let's hope this fixes it. That would be concerning if it didn't. Okay, cool. It's just the version. Okay. Cool. So yeah, once it starts, it should look something like this. I don't know if you can see it's probably really small, but you can do all sorts of interactions with the node. So yeah, I'll take that to start and then show that. You can see like the dev node is just building blocks every 3 seconds or so. So that's cool. Just show that over there. It's taking kind of long. If I have some other stuff like running on my computer or something, it's causing it to be slow. Okay. Oh, okay. Okay, fine, so. Okay. Okay, let me check and see that okay, maybe this server didn't start? Let me see if I have the other nodes running. Let me just kind of stop these for now. Whatever, I'll check them after. Okay. Find already in use. Oh, I have freaking Nosh running. Okay, so let me kill it. Oh my god, I can't believe
Fucking ganache problems.
Okay, now it should work. Wow, okay. Yeah. Watch for the port conflicts, everyone. Okay, now we should connect hopefully. Okay, cool. So yeah, okay, finally the front end showing. Okay, cool. So now you can see, yes, it's connected to Dawsomer, same version as before. It's the current block, current head finalized block. You can check out the node runtime metadata.
Show me the goddamn map, Amazon.
API usage. So yeah, it shows like what palettes and stuff are in the runtime. So the dev runtime runs just the Substrate default runtime, except configured to let the blocks be authored every slot. But otherwise, the logic is the same. So you can see also the dev node comes with a few pre-allocated accounts. So we have from Alice to Free, and they all have some mGOS. So I guess to start, I will just show transferring some mGOS, or some GOS. So the M is just the million GOS, or mega GOS. So I'm going to transfer from Alice to Bob. I'll do 1 mGOS, so you can actually see the units change. So 1, 2, 3, 4, 5, 6. Oh no, wait, this times that. Okay, cool, let's try this. So if this.
But
Okay,
now,
cool, so
oh,
cool,
now we're getting them.
Ready queue, and should be in the next block. Okay, cool. So yeah, so it was included in some block with the transaction hash, and we can see that the balance was moved from Alice to Bob. So yeah, so nice for doing some transactions, that kind of thing. You can also interact with all the palettes. So yeah, you can submit calls to the palettes, that kind of thing. You can query the palettes. So I can query, for example, let's check the current authorities, for example. So these are our current authorities. So there's Alice all the way to, I think, I forget what the ninth one is, like George or Ian or something like that. Yeah, you can query the palettes, you can check the spawn, that kind of thing, see our current spot. You can check for constants as well in the palettes, so you can check the epoch duration, it's 200 slots, expected dwell time should be 3 seconds, yeah, so 3,000 milliseconds. We can also make RPC calls to the node, so yeah, I guess the reason that the Dawsomer node just works with the Substrate front end is because the Dawsomer node implements the same JSON RPC interface that Substrate nodes do. So you can, yeah, so you can just call, yeah, you can call all the same RPC methods as Substrate. So we can do, for example, we can try to get some block hash for some block number. Let's get it for like block 10 or something like that. And then, so we have the block hash now, and now we can query for like the full block, for example. Okay, one, gonna work. We get header. Okay, interesting. Okay, so okay, interesting. I don't know why it's not working, but some of the calls work, so yeah, anyways. Cool, so I guess the last thing I can show is the runtime upgrade. So like I mentioned earlier, one of the big I don't know, innovative points I guess of Substrate is that the runtime is just some Wasm binary. So this Wasm binary actually lives on chain in the state tree. So you're able to submit a transaction to upgrade the state tree code, and as well that upgrades the whole entire state logic of the entire chain as well. So it's nice for some forkless state transition updates. So cool. So I'll show the runtime. So the runtime that I'm gonna update is essentially, so I mentioned earlier the Dawsomer dev node just runs the Substrate default runtime. So what I'm showing here is the Substrate default runtime, but I'm just gonna change the name to be Dawsomer node. So I'll quickly show the previous name of the node, or sorry, the name of the runtime version. So it was, so yeah, so you can see that the name was Substrate node, and the implementation version was 0. So I just updated this to be named Dawsomer node, increased the implementation version as well, as specified in the comment. So I already rebuilt this already. I'm not going to build it because it might take a while. So yeah, so I'm just gonna, what is happening? Okay, so cool. I'm just gonna try to upload that, and then hopefully it works. So Substrate target, debug, rebuild. Awesome. Cool. And then I also put instructions in the doc that I'll share after on how to build the runtime as well. So if you want to, I don't know, try it out yourself, you can do that. Cool. So let's hit that upgrade button and see what happens. Okay, cool. So it looks like it's gonna hopefully be included. So it's in the ready queue now. And it should be in a block shortly. Oh, okay, there we go. Cool. So you can tell a lot of stuff just happened. So yeah, so here we go. So the node detected a runtime code change, and it's upgrading this block hash. So the previous code hash was this, and this is the new code hash. So oh no, I previously fixed this issue. Okay, 1 second. Okay, this okay, sorry, I fixed this earlier and I thought it got merged. maybe it didn't get merged. Like, yeah, this should be correct. Okay. I don't know why that didn't work, but I'm gonna do that again. I'm just gonna reinitialize it. Well, the runtime upgrade worked, but then it didn't like the new runtime for some reason. Which I thought was fixed, but sometimes things don't work as intended. Okay, let's try this again. Okay. Cool, let me just like do a quick transfer to see. Check this will work. Okay. Also, let's query that system version again. Okay, it's queried. Okay, I'm gonna try upgrading again. Hoping it works this time. Not sure. It kind of didn't like it before, but okay, should be in a block shortly. Okay, cool, so it's now in a block. Gonna hope this works, but we'll see. Wow, okay. So this was fixed previously, and now it's not fixed, so whatever. I'm just gonna query the runtime version again. Oh, now it's working. What the hell? So it's like, okay, so it is still building blocks, but it's just a lot of error logs for some reason. Okay. Alright, I'll look into that after, but, cool, so I'm just gonna query the system, version again, and it should be updated to Dawsomer node. Okay, cool, yeah, so now it says Dawsomer node, and the version is updated from before, so runtime upgrade was successful. Error logs are just, false flag, I guess. But yeah, so that's kind of the, that's the front end, so it's, pretty nice for, if you don't need to deal with all of the stuff that Polkadot.js apps includes, such as like stuff for staking and like nominating values, that kind of thing. I think the front end is really nice for just development purposes and just like easily submitting transactions and that kind of thing. So I would highly recommend using it if you're developing with such an investment. Cool, so I think that's basically all for now. I guess I'll share this after, at the bottom post, I have a, another link to my previous talk I did earlier this year. That was like a bit of a longer talk, so there's a bit extra info in there if you want to read it, but, that's basically all, so hope you enjoyed. I can stop sharing now.
That was awesome.
Cool.
Like, I'm literally on this team, and live runtime upgrades still blow my mind. So that was super awesome stuff. We have a couple questions, if you have a second to answer a couple of these.
Yeah, for sure.
So the first one, and I think you are the person to give insight to this, is how did ChainSafe come up with the name Dawsomer?
I mean, I just came up with it. Like, I was reading a lot of books to find a good name for the project, and so I'm happy to say that the name came from William Gibson's Neuromancer, a classic cyberpunk novel. It's from like, so there's some sentence in there that has the word Dawsomer, and I said, wow, perfect word, I love it. So, yeah.
Beautiful. It's almost poetic.
It has to go, that's all I wanted. So, it's like kind of like an abstract word, I guess. It's like, it's one of those like unique words that you have in the English language. So I like
You're right. No, that's amazing. Great. Yep, it's the origin story. So, the next question is, do you know if there are plans to build Substrate in Go?
I would say Gossamer is meant to be Substrate in Go. Yeah, like it essentially, yeah, in that way, yeah, so our current focus is more on becoming like a Polkadot staking / authority node. But our long-term plan for Gossamer is to have it be like analogous to Substrate. So, yeah, like you will be able to, yeah, kind of do all the same stuff with Substrate that you can do with Gossamer in the end. So, in terms of whether there are plans, yes. So, keep your eyes peeled for it. Yeah.
Fantastic. Yes.
Yeah.
So the next question, great question. Are you to the point yet of benchmarking sync speeds versus the Polkadot client written in Rust?
Yeah, for sure. So, the sync speed in Gossamer, we haven't like formally benchmarked it, but I don't know if you guys saw when I was like running the node that says like the sync speed and just like logs it. But yeah, we have like some metrics I guess as well, but yeah, so this sync speed is a bit slower than Substrate at the moment. Not surprising considering, I don't know, we're Go and we're still like kind of in development, but yeah, I think the Substrate node, it also depends on whether you run an archive node or a full node. So Gossamer by default is archive, so it's slower. If you run a Substrate archive node and the Gossamer archive node, I think the Substrate node will be like, so it's like 50 blocks per second, and Gossamer will be like, I don't know, 25 or so. So it's probably like half the speed in general, I'd say. But same order of magnitude of sync speed, I like to say. So it's not like too far off, and I think moving forward we'll be able to hopefully reach Substrate speed levels. So yeah. And yeah.
Okay.
Compile time is way faster. Yes, as Dan mentioned, compile time is faster. So
True.
counts for
Yes.
Yeah.
So then the last question we have on the board over here is, what has been the most difficult aspect of Gossamer's development?
Okay, yeah, great question. So there's been various difficulties, I guess. I guess at the first year or so of the project, I'd say it was the most difficult just because there was a lot of new technology that we were using that had literally like never been used for this before. So I guess one of the main ones I can think of is the Wasm Interpreter. So I don't know if you guys know, but Wasm and Go are like not really best friends. Like Wasm and Rust are definitely way more compatible. So there weren't really a lot of like Wasm interpreters. Like there's only really like bindings to like Rust interpreters, and as well like just it's not really like something that's documented, like using Wasm in the backends like this, like because it's mostly for browser. So it wasn't really, yeah, definitely like there was no documentation for like how to use Go like this to run Wasm. So that was kind of the one of the hardest parts initially, I'd say. Yeah, just because it was super new, no one really had done it, and yeah, it was just complicated, I guess. But yeah, other than that, I mean, the consensus stuff has been pretty challenging as well, I'd say, just because like running an authority node that performs all the like block building and finality votes and stuff can be, it's just like so much stuff that can go wrong, and like if anything goes wrong, like you just really don't want that to happen. Like you need the algorithms to be essentially like perfect to go on mainnet. So it's just been taking like yeah, it's been taking a long time. It's kind of been really challenging in that regard, just getting all of that kind of interoperable, I suppose. So yeah, those are the main challenges. It's kind of long, but yeah.
That's pick from the list.
Yeah.
Well, great presentation. Thank you so much for joining us today. I'm super stoked to see what the future of Dawsomer is. I'm on the team, so that's part of the reason, but I'm stoked anyways. So everyone should keep up with it. Keep up with Elizabeth. She does awesome work. Thank you so much for presenting.
Thank you, Jimmy. Bye.
Yep. Bye-bye. Okay. So real quick, I wanted to give a couple reminders. If anyone has questions, and people probably pick up on this, but if anyone joined, please ask questions in the Q&A section during the presentation. We love questions. And we also have a networking floor located in the events tab, a drop down above me. So if you feel like trying to do some networking, feel free to hop on over there. But so right now, I'm going to introduce our next guest. It's Shapiro from the Mina Foundation. He is a graduate of CMU, where he got his BS in computer science, and stayed to get his master's working in the CMU personal robotics labs, which is super awesome. He worked as a software engineer for Mozilla, and then went on to co-found and serve as CEO for O1 Labs, and is now currently the CEO of the Mina Foundation. I'm super excited for this presentation, and it is my honor to invite Evan Shapiro up to the stage.
Cool, thank you for the...
Evan.
Hey.
Awesome, the floor is yours.
Cool, thank you. So first we're gonna try sharing tab and see if it works. And it does. Cool, okay. So when I was thinking about what to do for this, what to talk about today, one thing top of mind was some of the work that ChainSafe is doing on making it possible to have a Mina node that piles to Wasm, which then can kind of work everywhere in a really trusted way. And that got me thinking about what it would look like to actually kind of follow through on the full vision of this private, verified Web3 world with Mina as like a backbone. So this talk is me thinking through what has to be done to actually make that possible. So I hope that is interesting. So what do I mean when I say private and verified Web3? I mean making crypto internet native without any additional trust assumptions. This means that we want to be able to build things as developers on the internet and use the internet as if it was a crypto application with all the trust guarantees that provides, all the privacy guarantees that provides, which seems like that's a very powerful set of primitives. We could do a lot with it once we have the set of underlying APIs. So I'm imagining a world here where users can use the internet without disclosing any personal information. They submit some proofs of their information and some other ways of getting sensitive information on these applications without actually exposing the sensitive information itself. And they have tools to trust the information that they're presented on the internet is actually real in some sense. We kind of get this for free in a lot of ways on crypto. We know that the balances in accounts, for example, are backed by balances of transactions. It seems like there's probably some very powerful primitives you can build with this on the internet around seeing who in your social network, for example, has trusted certain web pages, or otherwise knowing the computations delivered to you by some centralized server actually are following some set of rules given crypto. So, and for developers, this is also some pretty cool set of things we can do. We want easy APIs to be able to access this stuff. We could imagine with this that a developer would be able to build an application that would take hold of any confidential information. So if you imagine something like GDPR, they don't even have to take ownership of that sensitive information, so they can avoid having to deal with all those regulations while still getting to like the API solutions they're looking for in terms of the actual functionality. And also I think with this you could imagine things being fully censorship resistant, fully on crypto in a way where you deploy it, you kind of know the guarantees around how it will stay up, and I think that can be cool as well when you're thinking about deploying an application. So to give an example of what this could look like, I want to give a couple examples. So the first is anonymous voting for a neighborhood. So in this example, you're going to go to a website, it's going to send you a proof of the state of some vote that's going to happen. So it's going to say, this is a vote that's happening, here's who's eligible to vote in it, here's the status of it so far. And then you want to send an anonymous vote, proof of your vote, and your physical address. So I want to say, hey, like here's a proof I actually live in that neighborhood, but I don't actually want to disclose this to this website where I actually live, and I don't want to disclose my particular vote as well. The application proves the result of combining everyone's votes, and then the site sends a proof of the new state so you actually know what the result of the vote is. So that sounds a little magical. We'll get into how we can actually do this later, but just an example. Another example, kind of closer to visit a site, it sends you a proof. This is just more for fun, not necessary for this application. Some of your friends are using this service without revealing exactly who is using it, so you know you can trust it. You send the site a proof of your identity, and in this example, I'm saying your identity is registered with a mutually trusted third party, just because that kind of makes it easier to think through. There's probably ways around that. You then send the site a proof of your credit history, both on and potentially both off-chain and potentially on-chain, depending on the state of crypto future, where there's some history actually built in on-chain in that future. So you can get the best terms that are revealing any of your information. So in this example in particular, you reveal proofs of things on and off-chain, but not the actual information itself. But that's used so that they can actually decide what kind of terms to give you. You receive a loan, and the loan provider has some terms set up, so if it can prove that you were non-compliant with the terms of the loan with the zero knowledge proof, it actually can prove that you were non-compliant and versus the rules you actually signed up for, then it can go to that third party and get your identity out. Probably not I think eventually it'd be nice to end up in a state where that stuff didn't even exist, but maybe as like an intermediate solution, at least in this world, you have full privacy end to end as long as you're compliant with something that is on-chain. That's pretty cool. So, what would we actually need to make this possible? So, like I mentioned, ChainSafe's doing work on making Mina full nodes verifiable in Wasm, which is definitely a big part of making this happen. So that's in progress. That's cool. Having Mina applications and data fully verified in the browser. So this is kind of done through Mina's succinct zero knowledge proof. But to have actual applications work for this as well, we need some kind of actual application layer, and this is what O1 Labs is working on with Snaps, which is in progress. There's actually a workshop on for the ZK Summit in a few days, so that'll be cool to see a preview of that. I want to say the docs are also out for that, either today or tomorrow, like it just happened. So anyway, that you can check that out if you're interested. In this world, also, users don't submit their data, they submit proofs of data back to the application. So they don't send their credit score, they send proofs of things. And then also we'll probably need a lot of libraries for this. Some of these are in progress, things like handling data storage, submitting data, making it easy to write these Snap applications. So I've put a little kind of work in progress in here, because some of those are in progress and just about to be built. But I'm going to talk about these three right now in terms of ones that how this can actually fit together once we have it kind of all working. So the Mina architecture today is as follows. So you have some validators, and they are one of them is elected to make a block. This is randomly by using their state. They choose some transactions, they make a block out of it, they submit that block with a little checkbox, which represents a proof, to the gossip net. That is then added to the chain of blocks. And yeah, so that's basically how it works. We can imagine that we have to add on some stuff if we actually want this to work on the internet. So for one, if we imagine everyone's devices connecting to a single gossip net and sending around these full blocks, that might be a little heavy if there's a lot of these nodes connecting. I think we'll have to actually see what the performance is. Maybe this extra step isn't necessary, but at least here I have a parallel gossip net that only is sending around proofs of the Merkle root of the ledger and proofs of the consensus state. So that's a much more lightweight thing to be sending around on a gossip net. So maybe you could have a lot more nodes actually involved on this. So then after that, you have your device which connects to the gossip net. They know from the guarantees of the gossip net they're not being eclipse attacked, and they can actually get the strongest proof of Mina on the chain, which gives them a proof of the Merkle root of Mina. This then leads to them saying, okay, I want to get the state of some particular account, say the account that has the voting information on it in our voting example. So now they have to do some API to request paths down from that Merkle root down to a particular. And what's cool about this is these data providers can't lie about the actual state of the application, because you know the Merkle root already, you can look at the path and you know if it's right or not, but they can withhold information. So I'll get to this potential protocol for this on the next page, where if you have any of these providers, as long as one of them is valid, we're good to go. Lastly, the client creates a Snap transaction in their browser by producing a snark proof just locally in the browser, and then submits that back to the network. Then they wait a little bit, and then the proof gets re-gossiped out with a new Merkle root. They check the state of the application, and then they know that the new state of the application is. And what's cool is that they're able to do this in a way that's fully trustless from their own device, which kind of starts getting us to a state where we can do the things mentioned in the examples in the previous page. Here's a brief idea for a protocol that allows us to do the data providing in a way that is fairly trustless. Say there are data providers that a client can talk to. We assume that at least one of these is responsive. We need one of them to be online for this to work. The web client locks X plus Y dollars with some conditions. If the client submits a proof from the data provider gets X dollars, the client gets back Y dollars. If the client does not submit such a proof in some time period, any data provider can, or anyone really, can submit a transaction that gets them the Y dollars and burns the X dollars. So then a data provider sends the client the account data and a proof of the data at the end of a Merkle path randomly determined by the requesting account. So this is something that no one has control over, this Merkle path, and presumably the client doesn't have it. If they had it, then they would probably also have the original data they're looking for. So this is something they need to get back from the data provider if they're going to be able to have that information. So the data provider knows that if it submits this data and the proof to the client, either the client will pay that back to the, will post that onto the blockchain, and the data provider will get paid X dollars. Otherwise, the client will have, if it doesn't submit that, will have burned X plus Y dollars. The client probably doesn't want to do that. And again, the client probably can't make the proof himself since it doesn't have a random Merkle path. So probably some more needs to be written up on this, but basically there's probably some good ways that we can make it so that you can fairly trust, let's say as a data provider, know that you're going to get paid for providing data to a client. So I think with this, we'd actually be in a place where we can start building small applications that are serving small numbers of users. But this leads to another question, which is if we wanted to do this in production at scale, what else would we need from Mina? So we would need much higher throughput, we would need instant finality, and we would need very low block time. Maybe you don't need all of these for all applications, but I was kind of thinking through, okay, what if we wanted to do this really at like a web scale? If we wanted to have all these things working, what would we need? So the Mina architecture today has some of the properties to make a smaller application that's more on the scale of what we see with appearance today, but if we want to make it bigger, we'd actually improve some of these things. So Mina right now has only one producer elected per block, so it has probabilistic finality. You need a bunch of these lined up in order to have guarantees that any individual block is correct. It's exponential, so you get it pretty fast, but still probabilistic. You have about 1 TPS, and you have about a 3-minute block time. 1 minute of that about is the time to make proofs, and 2 minutes of that is the time to propagate the stuff over the network. So let's see where we can start improving some of these. So for next steps in the game. So for one, if we want to have instant finality, instead of having it be that you have to look at many blocks with many different participants to get some certainty, we can instead elect multiple winners per block. So in this world, what we do is, instead of the BRF returning one winner, we have the BRF return multiple winners that then form a committee that then select a leader among themselves, and then that leader then produces a block. And then what happens is that block is finalized if you have enough committee members looking at that block. So that's pretty cool. I mean, this is like a bigger change to the protocol. I'll get into I think we need to basically embark on a project to start doing all these things. But this would give this full functionality, instant finality, with the additional properties I mentioned earlier. So, and then a path to improve throughput. So for one of these things, OF1 Labs is working on an improved networking layer, which will vastly increase the rate at which we can get things through the gossip net. So that should already be a big improvement. But another possible cool idea that we could do here, and something that is already somewhat of a prototype being worked on at OF1, is this concept of L1 level rollup pools. So you can have, instead of posting 10 transactions to the network, you can post a rollup for a particular account of 10 transactions, where you post only the hashes back to the actual chain. And what this you do is push much larger volumes of transactions onto the network, where from the actual protocol perspective and the Dawsomer perspective, you're only pushing one transaction, but that transaction represents many transactions that are rolled up. So this is somewhat, you can think of as rollups that are kind of native to the L1 in a sense, and can make it really easy for different applications to have their own rollups that then enable Mina to have much higher throughput in general. Let's say that with this improved networking layer and some other optimizations, you can eventually get up to, say, 100 TPS improvement. And then you can have these rollup layers that are each themselves doing very large throughputs, and you can have the opportunity to have very, very high transactions being confirmed back to the Mina mainnet. So I think that's a potential route, taking advantage of rollups to do that. Lastly, we have the concept of improving latency. So right now, there's two things that are keeping this slow. One is that actual proofs of blocks are computed with each block, which adds about a minute delay to producing a block. This is being reduced further. I would think around on the order of 2x, so it's still maybe around 30 seconds. But even so, 30 seconds is still kind of a lot when you're thinking about block latency. The other half of this
Block
is
latency
itself. Again, the new update to this should make it a lot faster. If this gets to a point where it's on the order of other networks around
Lord.
you can imagine being in a place where it's around, let's say, 10 seconds to do the propagation and 30 seconds to produce the actual block production. Still 40 seconds, so we want to make that better. One possible way to do this is to defer the proving of each block until later. So each block includes a proof of a previous block, but not the proof of the current block, so you don't have to wait to make that proof. So you can see an example here. If we're making block 4, we can include the proof to block 2. So when block 2 is created, let's call that time 0. Block 4 won't get created until block 3 is actually seen at time 1, but that gives us between time 0 and time 1 to make the proof to block 2. So in doing that, we have this whole chunk of time where Snark Whispers can go and make this proof. So by the time it's actually time to make block 4, the proof that we need to include for that block for block 2 is all ready and everything just included, and then we're good to go. So with that, when block 4 is time to produce, it can just be turned out really, really quickly. You can go over the gossip net, and very quickly we can improve block latencies. So to kind of put this all together, we would want to be in a place with this where we have multiple people making each block, so we get instant finality. We have an upgraded networking layer so that we can have higher throughput and we can have better latency. The proving is also deferred for higher latency. There's higher throughput because we have these roll-up pools that allow us to have many transactions in one, and the networking layer is a little better. So between all this, we can start getting into a place where we can start achieving this end goal of websites that are fully verified end-to-end using Mina zero knowledge proof and allow users to submit private data back to the chain. So, okay, so in summary, what does this all get us? So if we want to go back to this voting in the browser example, the user's client downloads the proof from Mina, and it does this by connecting to a gossip net, so there's no additional trust guarantees for consistency on top of the core protocol. And users get this entire proof of the application's particular history through Mina zero knowledge proof. User downloads paths to the voting application's accounts. So in doing this, they get pretty strong guarantees on data availability if there's any data providers, as long as one of them are compliant with the protocol, so they can go. User can submit their vote to the network with private information, so they can just submit proofs of their vote and proofs to the network, so they don't have to actually expose particulars about their identity or particulars about their vote to the network. And lastly, the network can process the transaction very quickly. This can be submitted to one of these roll-up application layers, which put everything together to get one chain with very high throughputs. We can have instant finality through many signers signing each block, and we can have low latency due to deferring the proving time and a faster networking layer for getting these proofs out to the network. So between all that, we can have applications that have all these properties together, which I think would be pretty cool. So in summary, clients can connect from the browser, from their phone. They get full access to cryptocurrency, all the guarantees you would want as if they were running a full node, and they get privacy when they interact with the chain. Developers can take advantage of sensitive information without taking on storage and privacy risks or having to think about the complexities of having to go through all the extra steps of making sure they're handling data typically that's good because they don't actually stick forward that data ever. It's all just running in the chain, the way it's still private. And also developers can get access to crypto infrastructure. Really, very few trade-offs. It's all running in the browser. It's all running just from them being able to connect to Mina through all this extra stuff that would run under the hood in this future world. So yeah, I mean, this is something that I'm very interested in seeing if we can help make happen. I think, this is probably a multi-year vision, but something that we can get Mina to do it, I think would just be really awesome to have and develop a good direction for it. So if you have interest in Mina generally, here's just the general link you can check out the protocol on. The Twitter's probably the place there to post what's going on. We're also looking for a developer advocate right now, so if you're looking to help build out some of these early Snap applications and help get the developer community going with what it would look like to be able to really easily build in JavaScript and TypeScript with zero knowledge proofs, you can check that out. There's a few other organizations you can check out too. That's all I have for this talk. Thanks for listening. I'm happy to answer any questions.
That's super awesome. Thanks so much, Gavin. Mina is super exciting, even from what I know even currently, so getting some insight into what the fever holds for Mina and some of what the vision is, it's super exciting. And we do have some questions over here. You're willing to answer a couple of these? So the first one is we have, what would you say are the pros and cons of using ZK proofs for verifying off-chain data, as opposed to like an Oracle network reaching consensus on the data?
I think the main difference is that it's really nice to have the ZK proof part of it because then you can have this privacy component. So I can prove something that has an Oracle but also has privacy involved. So I can say, hey, here's a fact that is signed by my financial institution, but I'm actually only going to reveal the part of that that's necessary to use the application, not the actual underlying data, which is very important for things publicly mentioned. I would say one advantage though of the Oracle system that I think will probably be temporary, but is the case of latency. In Oracle Network can come to consensus on something like a price speed much faster than you can produce
Curious, the follow-up on that, you said you view that as a temporary thing. Why do you say that? Do you think like ZK will progress to the point where it can rival that latency?
They're getting a lot faster, and yes. So I think basically at some point it'll be like the challenge of coming to consensus on like this integrated Oracle network versus just producing this local zero knowledge proof, and eventually that will get faster. It might take a while, but
yeah. No, that's super awesome. Thank you for that. The next question is, in an ideal world, when you submit proof of data, for example, a credit score, do you imagine the data is still stored in a third-party server, like Experian, or is instead owned by the user?
I think it's kind of a temporary state that we are submitting proofs of things that will be on third-party servers just because where the data is already. Eventually, it would be great to say, I've been interacting with this crypto loan protocol for a long time now. I built a reputation up. I'm going to show you my reputation is high without actually revealing the underlying data about those particular loans, for example, that I am working with. So I think eventually this will all be owned by the user fully. It's a kind of temporary thing, but it's really quite good.
Oh, cool. Yeah, I mean, that makes sense to me, kind of dependent on where the ecosystem progresses, I suppose, for that. So then, what part, if any, does Kimchi play in improving TPS and scalability?
It definitely helps a lot. So I want to say it's like 2x faster for proving and 4x faster for verifiability. So that just kind of for free gives us much faster block proving time and gives us much faster time for clients proving that. And also the verification speed improvements mean that it's easier to scale TPS as well because it's you can just verify more proofs in a shorter amount of time. So it definitely helps a lot with it.
Cool. So then, two more questions on here. So the next one is, if I'm not mistaken, there's work going into an Ethereum Mina bridge. What do you think are the most impactful ways Mina can interact with the Ethereum ecosystem, or whatever other ecosystem it
I mean, I think we're going to see things be very cross cross-chain. So I think, as an example, we could see a DAO that is deployed on Ethereum leveraging this voting scheme I talked about for it to be able to get anonymous, like censorship-resistant voting without having like very efficiently and easily. So this is a world where the Ethereum DAO said, okay, like we want these set of voters to vote on something. Mina creates a proof on its side saying, hey, like here's the result of that proof as a snap. Because Ethereum can fully verify Mina, the Ethereum DAO can go back and say, okay, I've seen this proof on Mina that says this, so everyone voted on this DAO vote. I can then apply the action of that on the Ethereum side. I think we're going to see like a bunch of completely things like that.
I definitely agree. I think that's a super exciting topic, and I'm very curious to see how that unfolds personally. So then the last question that we have is the thought experiment. I think that's what I meant to say. High numbers of consumers start deploying their own cloud clusters to host their personal graphs and run automated tasks. Would this scenario shift some of your objectives for architecture?
I think actually be very compatible. I think what would be really cool about this world is we would probably still want some kind of state layer. And this is probably actually the world we're kind of imagining, where we're imagining your own device is where your own data is owned and stored, but you still have to interact with some kind of public, kind of universal state for coordinating with other people when you're building applications. So in that world, you would take the thing in your private little node, which we're imagining right now is your computer, your phone, or whatever, but eventually you could also just simply host it. And you produce a proof of it using zero-knowledge proofs, and you submit that back to this kind of shared blockchain. So I think that those worlds are very compatible, and I think that the best of actually they're kind of both happen.
Awesome. Well, hey, thank you so much for joining us. That was an amazing presentation. I'm sure everybody here got a lot from that. We'd love for you to hang out. We know you're a busy guy, but thank you so much for giving us your time.
Thank you. No, it's great to be on and chat about it. So.
Sweet. Take care. And so we're gonna do another quick departure to the floor mode real quick to make sure the YouTube live stream stuff is all good. Like reset sometimes, we have to check in on that. So everyone bear with us, hang around, we will be back. Yeah, we'll be back. I loved all these presentations so far. They've been amazing. So just like give another thank you to everyone that's presented, and everyone else should hang around for future presentations because we have some great ones coming up. Just make sure that we're all good with the YouTube stuff. Ready to keep on going with presentations. So next up is a fellow chain saver.
systems could be like blockchains or cryptocurrencies, or actually they could be something totally different. You could be capturing, the state of people's Twitter activity or anything like that. So there's actually really no limit to what you can snapshot. And I think we've seen some interesting things in the past, but I think also there's like a lot of space to explore here in the types of activity that you can capture in a snapshot. And so the second phase is kind of this like calculation phase. So you're taking the snapshot and applying some function to it to calculate how much every new account in this new system should be owed in this airdrop. And this is kind of like what's going to be like our main design space. Like this is where we can get really creative and kind of account for different things that will lead to the goals we set up in the first slides. And the final stage is the distribute or make claimable. So that's either like dropping the tokens in people's wallets or making it some way that they can go ahead and claim these in the new currency. And so each of these steps, there's kind of like, some things we can explore and play with in order to get what we want. So let's take a look at the first step. The main question is, where would we want a snapshot from? And so that's a stake, like hammering a stake, basically get that. So where would you snapshot from? It makes sense to snapshot from another proof of stake chain, because likely there are actors on that network who both like know how to run a staking node and have the desire to do so. And so if we were airdropping to those people, chances are they'd be willing to move across and stake on our new chain. And there's also the case that we're not limited to a single location. I don't know if I've seen this happen before. I wasn't able to find an example, but there's no reason that you have to snapshot on Ethereum and then drop to a new chain, or a snapshot on Cosmos if you're deploying in Cosmos Node. You can just do a whole bunch of them and reward people accordingly. And it would be cool to see an example of that. And so the second phase, the calculate phase, this is where things start to get a bit more interesting. So what could we do in terms of calculating? Let's assume that we're snapshotting wallet balances. Oh, I think I forgot to mention that like in the snapshot phase, like it's important that this is like super red. Normally you would take a snapshot and then announce the fact that you're doing an airdrop and that the snapshot is already taking place to avoid any kind of gaming of the system. Okay, so say we captured wallet balances. How are we going to calculate what the proportional amount that each wallet should receive? So one way we could do it is make it actually proportional to the snapshot balance. So if you have 10 atoms, you will get 10 times some number of added new balance. Or the other way we could do it, I guess, is giving like an equal amount to each account. So if you had an account in Polkadot, each one of these gets 5 new tokens on the new network. And both of these have been done. I guess the equal amount's kind of similar to the Uniswap drop a little bit, although I guess it had the condition that you'd previously interacted with the DAC. But is there something else that we could do, and what would be the problems of each of the ones above? And so like there's a pretty clear problem that comes with proportional rewards or proportional drops, and we can kind of quantify this a little bit. So this plot shows all of the accounts on Ethereum basically broken down into 20 separate bins, and there's like an equal number of accounts in each bin basically. So you could say that each of these is like a 5th percentile of the accounts. And then the y-axis is the mean balance in each of those accounts. So on the far left you can see like these are all the accounts with a balance. Oh, it's a cockatoo. It's just flew into my window. So these are the balances with like like a small number of ether between 0.099 to 0.1, and then all the way up to the higher end of people holding between 25 Ether and like 2 million Ether. And you can see that like if we take the mean of each of these bins, that like the upper 5th percentile like just dominates the entire thing. So if we were to airdrop proportionally, then the upper 5th percentile of Ether accounts are going to dominate our new thing. And depending on how many people are in this top 5th percentile and what their motivations are, it doesn't necessarily seem like the way to have a healthy functioning economy. So like I would imagine that a lot of these upper 5th percentile accounts are exchanges, or I guess you just good old-fashioned whales. And so there's potential for them to kind of wreak havoc. And so taking some cues, I guess, from Gitcoin and the idea of quadratic funding, there's this notion of a quadratic airdrop. And so in a quadratic airdrop, instead of just distributing the new currency exactly proportionally, you kind of raise the snapshot amount to some exponent k between 0 and 1. And so if we take the extremes of this range, if k is 0, this means that it's an equal drop per account. So every account is the same. Plus, or if it's 1, this means we have the linear increase with balance. But we have this range in between which we can play with. And so setting it to 0.5 would be like a square root roll-off, which I think is the same as the Gitcoin quadratic adjustment. But actually we're free to play with this. And because you would already have snapshot the different balances, you can kind of adjust this parameter and see what impact it's going to have on the distribution across your snapshot. And so I guess just a quick visualization, although maybe this is like obvious, but like for different values of k, you get kind of a different roll-off as the snapshot balance increases, and you can kind of visualize it this way. And so effectively it has the effect of increasing the amount of the relative amount given to smaller accounts and decreasing the relative amount that would have been given to larger accounts compared with the linear model. Cool, okay. And so this becomes really interesting when we actually kind of visualize it on the plot I showed previously. So these are the different values, or some different values of k, and how they adjust the mean reward for each of the bins. So on the left is the same plot as before, with k equals 1. But in the middle is k equals 0.5, and you can see that now, as I guess mentioned, on the far right they've kind of been compressed, and on the left they've been expanded. And it looks like a much kind of healthier distribution across the range of different wallet balances. And taking k to 0.25, you can see that we're approaching the kind of level thing. And so, yeah, because you would have access to this data, you would be free to kind of adjust this, and based on some requirements you might have, kind of figure out like what's a nice shape of curve that you'd be happy with for your distribution. Okay, and so that was kind of like the quadratic airdrop adjustment, but what other kinds of things might be useful? Remember that we're still following this goal of trying to bootstrap a proof of stake chain. And so it might make sense to give extra rewards to accounts that are already staking on the snapshot chain, if it is indeed a proof of stake chain or chains. And it's reasonable to assume that they might stake on this new one, particularly if they're getting extra rewards from that.
Hi. Howdy.
And so our airdrop strategy is kind of growing in its name. It's now a quadratic stake-weighted airdrop.
Hi. Oh, yes, that's a lot of kisses.
So in this model,
That's a lot of kisses.
the amount you receive in the drop
Yes, it
is
is.
proportional to
Mwah.
our kind of quadratic term from before, multiplied by this new factor, which would be the number of unstaked plus sigma times the number of staked divided by the total. And this adds a new parameter and something for us to play with. And so this new parameter sigma is the extra reward factor. So, for example, sigma equals 5 would mean that for every item of the currency on the previous chain you held that was staked, you would receive 5 times more reward for that. And it's all adjusted still by the quadratic curve. And this strategy was used. I can't actually remember the name of the chain. I think it was either a Cosmos or a Polkadot one. But this idea of a kind of stake adjusted airdrop has been used in the past. And I mean, there's so many more different things that we could do in this calculate phase, but I mean, I'll just cover a couple of them. But by the end of this, we should now have a list of accounts that are eligible to receive a drop. We should have some amount per account. And this, just to clarify, like this should be totally off-chain. So, our snapshot was done on-chain, but we took the data off-chain and we did this entire kind of adjustment thing off-chain. But crucially, it should be publicly verifiable. There needs to be a way for people to, like, also go and recapture the snapshot data. So you should have released the block height, maybe, or some kind of other way for people to unambiguously find the data that you snapshot from. And then all of the calculation and the function that you applied to it should be made public as well. So people can also go ahead and apply the same function and check that they got the same thing, and that you aren't injecting malicious airdrop balances in there to give extra to you or your friends, or whatever your motives might be. And then there is the final phase, the distribute phase.
Hello.
And so, how can we go about doing this? So if we're launching a brand new proof of stake chain, which was the goal, there's no need to kind of worry about this too much, because you can bake the allocations directly into the Genesis block. And I think most of the kind of blockchain frameworks would have a way to do this, certainly in Polkadot and Tendermint, SDK. But there's kind of one consideration here, which is like, you don't actually know that all the things in your snapshot are actually live accounts, and you don't know that they're actually interested in receiving your new currency. So there's a possibility that like a huge chunk of your circulating supply could be kind of allocated to these inactive wallets, which would just be like a real shame, and it seems kind of unnecessary. And I guess like, yeah, it's just not a good way to kind of start off a whole beautiful fresh currency. Like I suppose people have a pretty good idea about which bitcoins have been lost and are in locked wallets, but if you did get to start a whole new one from scratch, you wouldn't like to start with a whole bunch of it lost. And so one way to kind of work around this would be to have a registration period. So this would take place on-chain somewhere. I guess it doesn't necessarily need to be in the chain that you're launching or the chain that you're snapshotting from. But I think either of those would probably be a smart choice. And yeah, participants would need to register by providing some kind of proof of ownership of an account, which the easiest way to do is just by providing their public key signed by the private key. And so this would be like a fixed term for registration, and after it closes, you would distribute the total airdrop allocation among the registered participants, ignoring those that didn't successfully register. So this seems like a good way to kind of like avoid this problem and make sure that the people who are airdropping to are actually those that are interested.
Hello. Oh, you're so pretty.
And so in the calculation
you're so
phase,
crazy.
what you're calculating is not necessarily the amount that it should receive, but I guess kind of weighting per account. And then after the registration period, you would remove all of those that did not register and use the weights to allocate the airdrop allocation. And Another kind of thing to consider in the distribute phase is that you don't just need to kind of give it to people for nothing. You can kind of make them work for it, and you can use that to influence, you know, positive behavior that's going to help your network from the start.
Oh, that's so pretty. Oh, that's so pretty. That's a lot of kisses on my ears. That's a lot of kisses on my ears.
Before you actually are eligible to receive your airdrop. Or maybe you receive some chunk of it for each time you vote.
Hi.
Another really interesting one is that you have to actually, you know, participate in the staking. And you could actually have the airdrop rewards held in some kind of escrow and released as additional stake rewards. So all of those who were airdrop eligible who then go on to become stakers would, at least in the earliest parts of the network, would be receiving like these additional stake rewards from the airdrop escrow. And that seems like a really good way to kind of incentivize stakers to get in there early and you know, make sure the network is secure as it can be, like right from the genesis.
Hello.
And so to kind of summarize our, you know, design space when coming up with a kind of fairer, safer airdrop, the first step is snapshot, and you've got to make sure you're doing it secret, because otherwise people can get in there
you fell.
and kind of manipulate the results. And you're not limited to capturing you know, just balances from one chain. You can capture any kind of stake on any number of chains or non-chains.
You're so pretty.
You've got a lot to work with there.
You're so pretty.
Next you want to calculate, and this design space is like pretty huge, and there's a lot of room.
I got your leg. I got your leg.
And it's important to consider that all of the decisions you make here are going to affect you know, all of the accounts. But because you have the snapshot,
you got my
can
thumb.
actually see that effect that you're going to have, and kind of make sure you manipulate it to get something that you want. You probably want to have a registration to ensure that your circulating supply doesn't end up uncirculated.
All right, we're
you can have,
ready to start adding a
incentives,
bunch more shit.
And you can kind of make sure that people who are interested and joining the network do things that are useful to you to make it safe. And then finally, if all went well, you can kind of launch with this sound new economy without having to have an ICO.
Oh, hi.
And so the name of our kind of strategy has kind of grown a bit over the few slides, but I think we would call it a quadratic stake-weighted registered stake.
Come here.
Which I think is a pretty cool.
Hello. Hello.
Awesome.
Howdy.
And I guess as I mentioned at the start, and probably every other chain safe person to present so far has mentioned, but we're hiring like a lot. And yeah, it's just the sweetest place to work. I couldn't recommend it highly enough. And in particular, yeah, if you're interested in this kind of stuff, or prototyping or research in general, maybe a job in the solutions team is for you. So yeah, be sure to check that out. If you want to hit me up, these are my handles. Probably Twitter's not the best, but Discord or Instagram, GitHub. Feel free to reach out. And thanks for coming to my session.
Awesome. That was sweet, Willem. That was a great presentation. I love that. And it seems that a lot of people did, because we have a good amount of questions for you if you're willing to take on some of these.
No worries, I'll do my best.
Sweet. Okay, so the first one I'm going to throw at you is there a project that you know of that has exemplified the most fair airdrop to date? And then maybe if hopefully they don't mind, if I add on a little part of that, is the definition of fair ambiguous? Is there a concrete definition of what fair means in this sense?
Oh, it's totally ambiguous and like totally subjective. Like, but it's a funny thing. Like, I guess you have a lot of power, right? If you're the one kind of like setting the parameters for an airdrop, it's like a pretty unusual position to be in. But no, I just called it a fair airdrop because I thought it sounded cool. It's not necessarily fair at all.
Yeah, I mean, it sounds fair to me. But so then, is there a project that exemplifies fairness best in how they've done airdrop, like in your opinion?
Yeah. So obviously, like I tried to find all the examples of airdrops that had ever happened. when I was doing this research originally. I think like in general the bar was set pretty low, but people were in more recent times starting to get pretty creative. I probably won't drop in names of projects, but like yeah, like the idea of doing a quadratic drop and a stake drop kind of came from some projects launching on Cosmos, and I thought that was pretty cool. So that seems to be where the kind of innovation was happening.
Sweet. So, if any of these, like, if you don't want to name drop, just we can move on to the next question. So,
I was
if you
really
don't
taking
know,
up the entire time.
yeah. So, the next question is, in your mind, did you view the ENS airdrop as a fair approach at rewarding early adapters? And like I said, if you don't want to comment on specific projects, we can go to other questions.
I don't even know if I'm familiar with that one. Is that like a really recent one?
I think it did happen recently. Through a naming service, I think there was a relatively recent airdrop. I don't know the details on it though.
Yeah, I can't say I'm familiar with it, so it might have happened after I did the initial.
Yeah.
I guess I can't really speak to that one, but yeah, I'll look into it.
So then the next question we have is, what's a good real world metaphor or analogy for airdropping that illustrates the difference between a fair and unfair airdrop? Like what does that mean and what does that look like in other situations?
Yeah, so I guess like, yeah, as I mentioned, like the idea of fair is like pretty subjective, and I guess what we were really designing wasn't necessarily a fair airdrop, but like a safe and effective one, from the interests of the people trying to launch a new proof of stake thing. But an analogy for the real world, like maybe from economics or something like that, definitely not our current economic system. Gee, I don't know, that's like a really strange question. I like it. Because like, does this stuff kind of happen in the real world? You know, like do currencies kind of get bootstrapped and like dropped? And like, I guess they must have done, right? Like,
like a digital allocation.
Someone like creates a whole new currency in the real world.
Yeah, that is like how like a centralized currency might just do an initial distribution of their currency.
Although that it must have happened, so like yeah.
I mean, it came from somewhere.
Yeah, totally. Stimulus check by the US government? I guess it's like a thing because like
yeah, US airdrop.
Because you can't really do like a civil type of attack on things like that because like the government has a pretty good idea of like who everyone is. So like, you know, it's not quite in the same space as the crypto ones. Just because of like the dissociation between like actual individuals and accounts.
Well, cool. Thank you for that. Yeah, a good question to ponder for everyone.
These questions are awesome.
Yeah. So then the next question is, are these approaches and solutions that you've talked about in your presentation, are these concepts that already existed or have been used, or is this stuff that you've kind of come up with in your own research?
Yeah, so definitely the quadratic air drop has been used before, and the stake drop has been used before, and those are the kind of main two that we kind of latched onto just because they're pretty cool ideas. And so like, yeah, I guess this presentation was less about like prescribing a thing, but more about like prescribing the design space and like where you can start fiddling with things. And so like, yeah, it was more of a kind of, you know, a rallying call and like you know, let's start getting a bit more creative and interesting with drops. But yeah, like those two main things, I guess that I spoke about have both been used. I don't think they've been used together, but I think they've been used separately. But I could be wrong. It all happens so fast.
No, that's awesome stuff, and I think it's great to think about because it really is important when you're designing a system, and if you desire it to be fair, then it's definitely stuff you have to think about. So great work. I don't know if you're going to want to answer this one, that's fine, but what's been the worst airdrop you've seen so far?
I think we've all seen the ones that just like drop to every Ethereum address. Like you just like check your wallet one day and there's just like 10,000 random things of some kind, and like maybe not anymore because it's too expensive to do that. But like I remember that kind of happening a bunch, and like they're still worthless. So like it was obviously a very unsuccessful like airdrop. So it would have cost them like so much in gas to like launch a contract that has a balance in every account, and it's led to something worthless. So I think that's an example of like exactly the kind of thing that we're trying to avoid.
Yeah, my favorite part of that is that the number you picked was 10,000, which is like just it'll go to $1. It will, I swear. So we have 2 more questions on here. So if you're participating in governance, like you said, earning your portion of the airdrop through like staking or participating in governance, does that mean that you'll be participating in a non-token based governance system in that point, or for staking, how would staking work pre-airdrop?
Yeah. So I think this would be, at least the way I've seen this done before, is that if you remember, like, actually no, I didn't have a slide for that, but you would receive some portion of it in advance, and then be able to receive the remainder of it from doing the incentive kind of tasks. And so yeah, like obviously, like if it's a stake drop, you have to be able to stake something to then receive the bonus as rewards. So you have to receive a chunk first, and presumably, yeah, if you're voting, it would be like weighted voting, and if you're staking, it's normal staking, and then you would receive kind of bonus that way. But you have to receive some originally for it to work. Yeah, for sure.
Okay, cool. Yeah, that makes sense.
Yeah, that wasn't really clear actually, was it? Yeah.
Well, I don't know. I mean, it could be to where like a non-token based voting system rewards tokens. Like, I don't know. Maybe there's different avenues there. I don't know. But so we have one more question from Phil. So, do you see many similarities of airdrops with traditional fundraising with VCs, angel investors, or IPOing? Are airdrops, if designed responsibly, a step in the right direction for advancing finance?
Gosh, definitely not my area of expertise. I don't even know what half of those things are. But like, yeah, I guess like we all kind of lived through the era of the ICO boom. Or maybe we all didn't, but like I think a lot of us would have. And like, it seems like people are really moving into different things these days. And it seems like the airdrop's kind of growing in popularity at least. And like to me it feels like a step in the right direction. Particularly for projects that don't necessarily need to raise funds. Like I guess that was the funny thing about the ICOs is that like, you generally could make a token contract pretty cheaply. You would get all your money and then you would start working on the project. Whereas I think like an airdrop's more appropriate for when you actually have kind of completed a project and then you're trying to just bootstrap the economy. To me, it seems like a step in the right direction, but yeah, I'm sure there would be like a pretty fun discussion to have around this, and maybe we can later in the conference floor.
Awesome. I think that's a great answer. I also think and certainly hope that it's a step in the right direction. I think so. Great stuff, great presentation, great answers. As always, thank you so much, Willem, for sharing your time. You do great work. We appreciate it, and keep it up. And yeah, again, thank you so much for the presentation.
Thank you. That was super fun.
Sweet. See you later. Okay. We have, yeah, there we go. Willem's screen remains. So yeah, we have 2 more presentations today, and a reminder that we are going to continue networking and hanging out after, so please stay around, hang out, talk with us. I think we're pretty chill. Hang out, talk about presentations, whatever it is. Come hang with us. Another friendly reminder to use the Q&A section to ask your questions during presentations. We love questions, and I love the questions we've been getting. We've been getting some awesome questions. So yeah, keep it up, everybody. Again, we have the up in the events drop down up here. We have the networking floor, where if you want to go network and talk to people, that's the place to do it. Otherwise, hang around here. And I will say, if you somehow haven't picked up on this up to this point, ChainSafe is hiring. We would love to have you. We need people. We're looking for more people, and we would love to have some great people, great talented people come and join. So yeah, if you're interested, ping any one of us. Feel free to reach out. And so our next presentation, we have Victor Liu from StakeDAO and Graham Tompkins from Stateless. Victor participated initially with a bunch of different stuff and got he had a Gov token for both on Ether Payments with StakerDAO, and then was elected to be part of the strategy committee. And then we have Graham, who is now he's former BD from StakerDAO, and then now he is the co-founder of Stateless Money. And we have him here right now. So awesome. I'll pass it off to you guys. I'm excited for this.
Hey guys, thanks for sticking around. Great, Victor's here with me as well. I'll go ahead and get started here. We're going to start by just talking about Pint, the Polkadot Index Network token, and then Victor's going to pick it up and talk about how we were able to make Pint possible through the StakerDAO community treasury. So Pint, in short, is a on-chain index token for the Polkadot ecosystem. It allows someone to easily gain diversified exposure to some of the best Polkadot ecosystem projects. Here's a couple of links that you could follow and read a bit more about us. You could, of course, look into the GitHub repo directly, as it is open source. So looking at this screen, it's obvious to everyone here that there are a ton of interesting and exciting things going on in the Polkadot ecosystem right now. The projects, parachains, the companies that are building interesting things. There's really a plethora of them, and it's really exciting to see, especially if you're working in the space day to day and understand who's doing what. From an outsider's perspective, however, when we're looking at a screen like this with all of the cool projects being developed, it's an intimidating thing to look at. From an outside investor's perspective, looking at a list, for example, of the S&P 500 and trying to pick winners, that's a hard job, if not impossible. I think in traditional finance, most individuals have, or at least should, go to things like index funds to make more risk-adjusted and diversified investments. So for most people, the best idea is usually an index fund. Index funds aren't for everyone. They aren't for probably a lot of people on this call that are quite a bit more familiar with individual projects, the technical capabilities and their ability to deliver the vision they want. But for the average person, I think it's safe to say that an index fund is the best way to invest in an ecosystem. And we believe that Polkadot ecosystem is in a great position to have one to allow for newcomers to capture some of this value that's being created so early. And Pint, in short, is an index token. It's a fully backed on-chain token that has a curated set of assets behind it that governance chooses. So the governance will choose which assets are included, as well as their allocations within this index. As mentioned, it's governed as a DAO. So there is a council that governs all of the parameters of the index directly and how it operates. It is fee-based, and there is a buyback and burn mechanism. So the buyback and burn mechanism, I'm sure we're all aware, if you are staking assets like Polkadot or any of these other parachain assets, you will get a small reward every so often to pay you back for staking those assets. What we've chosen to do instead with the assets that are staked within Pint is to aggregate those rewards and then use them to buy back Pint. Governance then decides what portion of those rewards will be burnt, in effect distributing those rewards through aggregation of value or consolidation, kind of like a share buyback rather than a dividend distribution. Governance then, of course, decides what percentage to keep as a fee for operating this product, because
take my coffee because you might try to be sneaky.
sovereign, self-sustaining DAO. So this treasury is going to be used to compensate the governors as well as community members who are working to ensure the best index product possible. Why do we need this? Well, number one, simplicity. For most people, the researching, holding, staking, all of these things are quite intimidating. So being able to recognize that the Polkadot ecosystem is quickly developing and there's a lot of interesting projects, the most simple way to get involved is sometimes the best. And especially if it's a diversified entry into the ecosystem. If somebody from the outside hears of one or two projects, they'll likely be too intimidated to look into the many other interesting projects, so they'll be consolidated into one or two of these tokens specifically. And then there will be other index or indices offered by exchanges and centralized service providers, but we feel that a on-chain, DeFi accessible, DeFi native index is the best idea for the ecosystem as well as the people involved. Having governance and management on-chain is incredibly valuable, as well as knowing that any assets held in the index are all managed on-chain as well. Gives people, or should give people, a bit more insight into how things are being done, managed, and how the governance will evolve over time. So Pint is initially intended for at least two different entities. Of course, there's the average person that is excited about Polkadot, eager to capture some of this growth, but is unsure about the entire process behind it. Doing the due diligence into each protocol to determine if there's noise or value, to figure out how to buy and stake their assets, to choose a validator. All of these things I think are quite intimidating for some people, and they are probably or most definitely too busy to actually participate in the governance of these assets. So as the protocols distribute this governance token, most people I don't think are going to be able to stay up to date, especially in the long run with the governance progression of that protocol. So they simply don't care about it and can't stay active in governance. And then protocols I think will be quite into Pint as well, or index products on Polkadot, because they probably have a concerns community that is a bit technically limited by how their on-chain treasury works. They might be generating great revenue, have that treasury rising, and may have tens of or hundreds of millions of dollars sitting in a treasury in their own native token. That native token, of course, is incredibly volatile, and it's a central point of risk that communities are going to have to deal with. So we believe Pint will position itself nicely as a treasury reserve asset for a lot of these protocols, and communities may decide to take 1, 2, 3% of their native asset treasury, add them to the Pint index in return for greater diversified exposure. So protocols could reduce their risk slightly holding 100% native asset treasury to have a slightly more diversified exposure to all of the other interesting projects in the ecosystem. Additionally, protocols will likely enjoy the investor type of people holding indices. For example, an index holder is typically a bit more long-term, less short-term speculative and looking for that price pump. They understand that the gains are much more diversified and spread out across the ecosystem rather than the short-term runs of individual tokens. And lastly, protocols that include their token in the index are also able to qualify for parachain lease offering financing far into the future. Once the Pint treasury is robust and generating substantial revenue, protocols included in the index will be able to actually apply for financing for a PLO, for example, or utilize those funds held by Pint. And if approved by governance, it could be a viable tool for long-term financing for these PLOs. So governance of any DAO is, of course, one of the most contentious points. I think we found, or I found personally, that having very active community governance gets quite tolling, and there's often a governance fatigue that sets in a lot of projects. So rather than have everybody involved in every decision-making process in Pint, we decided to start with a consolidated council of 7 people. We have representatives from Akala, ChainSafe, Hashkey, Hypersphere Ventures, Parity, Polychain Capital, and Stateless Money. And so this council is coordinating its efforts to get Pint off the ground, get it Soon after that, we want to include as many community members in the governance of Pint as well. So we imagine that community members will be writing in proposals to change allocations, change structure, set up new types of parameters, for example, and governance for Pint. And this is where we want to change the 7-person council to include any community members that are actively participating. The second layer of governance after the council being the most active managers of Pint, is the Constituent Committee. This Constituent Committee is a rather passive layer to governance. It includes a representative from each asset that is held on the index, and this Constituent Committee is able to retain veto power over the council's actions. So if there is a proposal to do something that the majority of the Constituent Committee members don't like, they're able to veto that action. And the Constituent Committee is also able to nominate new council members. So the council grows with those that are supporting and acting as the constituents in the index want. And we've created governance like this to have not an adversarial approach, but ensuring that the assets that are included in the index are very much in control of the index themselves. They don't need to manage the day-to-day intricacies, but they are able to manage the council who does manage the day-to-day intricacies. So this is very much a index created for the average person who wants to gain exposure, but also for the assets that are actually included in there. So giving these protocols good control over the index that they can participate in and gain stability from. I didn't want to get into many of the technical aspects of how Pint works today because Matthias and Redwin of ChainSafe will actually be giving a more in-depth talk tomorrow about XCM and how we were able to utilize it in Pint to offer this product across parachains with a lot of different assets while being able to coordinate an on-chain product where anyone will be able to mint and redeem Pint natively in a trustless way. So now I'd like to introduce Victor from StakerDAO, and StakerDAO being the project that made all of this possible. ChainSafe and Stateless Money coordinated and built the Pint project. The StakerDAO and the community from StakerDAO were actually the financiers behind Pint, and we were able to make it happen with their work. So Victor, if I could invite you on now from the strategy committee to keep on going.
Sure. Thank you, Graham. So now I will talk about StakerDAO, the cross-chain asset factory. Now go to the next slide. So the special thing about StakerDAO is that now we are in the process to be more decentralized, but also we are present in many different chains such as Algorand, Cosmos, Tezos, Ethereum, and Polkadot. So from my first experience actually by being a customer of StakerDAO, where Graham was the part of the business development team. So my first product was also an index product called Blend, which also consists of 4 different assets, which also include Polkadot. So now to the next slide. So the way it works, how we came to this project. So Graham introduced a new kind of index product with ChainSafe. The way it works was basically that they proposed the concept how it works. So we, the Staker token holder committee, decided to vote whether we want to have this product in place, and we basically funded with our treasury to make sure to make this into a reality, because this is what we as a cross-chain committee would like to have. And we also have roadmaps as through the success of Blend and also Pint. We also decided to have a broader roadmap, what StakerDAO will do. Next slide. So for roadmap, we decided that we have to continue to decentralize stake it out, which means that we need more members. So that means like the current strategy committee that we have has to be enlarged. That means we need more members and also subcommittees, which has different expertise. And also through the experience that we have by having index products, web product, we are planning to introduce new products as well, and as many new chains as they are now emerging through a stake it out incubator. Since we are now represented in many different chains, especially on 5, that's why it's very important that we need community representation, because we, the committee, we have a lack, we cannot be an expert of every chain. That's why we need dedicated people like Graham, who is a expert in Polkadot, to make sure to inform us about the trends, what we have to build, what we can build on. And for all these 3 steps mentioned, we hope that we are able to increase the membership in our community and have more community member involved as well. So thank you everyone, and if you have further questions, then ask me or Graham and join us for a pint.
Wow, great ending. I would love to join you for a pint. No, super awesome presentation. I mean, as a change saver, I'm super stoked on, I mean, and some of the tech within the Polkadot ecosystem. This is all awesome. I'm super stoked on it. And we do have some questions for you guys, if you guys have a moment. So the first one is, how far off is Pint away from participation in the parachain slot auctions?
So let's take a step back here and talk about kind of the long-term vision and how we're implementing Pint. This kind of goes into one of the questions as well. You know, the Pint palettes and everything that's being developed today, the grand vision here is for anyone to come in and be able to manage their own sort of ETF or index-like token on-chain. So theoretically, someone could start developing thematic indexes, such as you know, a DeFi-based only DeFi native token on Polkadot to launch, or very specific groups of assets. So this is a vision that we're playing with in the long run. That would be a parachain that would allow for structured financial products to launch natively and be governed natively on Polkadot. That's quite a big thing to imagine. So we've decided to start it back with a much more scaled approach. And that is simply launching as our palette integrated on the back of another parachain. So it looks like we will integrate the Pint palette with a collar, and we will have a launch with a collar to do this natively within their parachain. So we won't be launching our own parachain per se, but we'll piggyback as an integrated palette on others until we've determined that there's significant interest for other structured products that we can then go and launch. To follow up on another question, Jimmy, if you don't mind me just going through them.
Please, go ahead.
Does Pint have plans for a Kasama variant? Short answer is yes. Like many different assets in the Polkadot space, you know, there are wild cousins that will launch on Kasama. We believe first a launch on Mandela for all of the testing with project tokens will come first. We will likely have a Kasama cousin coming quite soon after that. The name we've been considering is Shot, because Shots always come before Pints. So we'll launch on Kasama as a Wild West testnet, just as it's intended for, with the goal then to launch in Q1 sometime on Polkadot as well, once a handful of parachains are integrated and XCMP is working well.
Awesome, awesome. I mean, they don't always have to become Pints.
True. Get them as you please. And someone said, where can you buy Sacred DAO token? Yeah, go to CoinMarketCap and figure that one out for yourself. Pint is going to be a DeFi native token, so we're really focused only on DEXs and to exist primarily where DeFi exists.
Awesome. that sounds super great. Amazing stuff that I know we're all. Oh, another question. In the long-term vision, does it mean that StakerDAO and Pint will offer possibility to the community to build their own Pint index?
I'll speak for Victor here, but please do add in, Victor, if you'd like. I guess that's not even in the long term. Well, assuming Pint is live and people are able to create their own customizable indexes, then the answer to your question is yes. But in the short term, the answer to your question is already yes. I know the StakerDAO community is looking for interesting proposals to finance. So if you do have an idea, just head over to the community and understand what the willingness to accept your idea and finance your idea is. So there is the possibility to have your idea financed by the StakerDAO community treasury if you find traction and are able to deliver a viable proposal to them. And for Michael, are there plans to bridge Pint to any EVM chains or as an ERC20? Yes, I think likely just how the ecosystem is evolving in general, that we will see many Polkadot assets go over to ERC20 assets and become accessible. So I think the viability of having Pint as a treasury reserve asset will likely expand to protocols on Ethereum as well, who might want to further diversify outside of what they could access today. And yeah, participate in the StakerDAO community. I think the best option is typically Discord. So head over to Discord, join the channel, and join us in the Pint discussion channel or any of the channels that you might be interested in.
Thank you guys so much. That was an amazing presentation. I hope everyone goes and participates and checks them out. It's all great stuff. So thank you guys for your time. We loved having you. And yeah, thank you so much.
Great. Thanks, Jimmy, and thanks everyone for sticking around.
Yeah, absolutely.
Thank you.
Okay. So, gonna just another reminder, QA, we love our questions. And then we have the networking tab. And after this, we're gonna be hanging out, chilling. Come hang, come network with us. Do whatever we will do. Then just, yeah, come hang. And so, our next presenter, he's all ready to go, is Dr. Hank Korth from Lehigh University, professor of computer science and engineering, and the director of blockchain lab of Lehigh's blockchain lab at the Center for Financial Services. His previous work experience includes he was the director of database research at Bell Labs. He was the vice president of Panasonic Technologies and was assistant professor at University of Texas at Austin. Since coming to Lehigh, he spent 7.5 years as the department chair and served as the co-director of the computer science and business department from 2012 to 2020, which just happens to be the program that I graduated from. He's the co-author of the leading database, or one of the leading database textbooks, Database System Concepts, which is currently in its 7th edition. He's a fellow at ACM and IE. He is a member of Lehigh's Scalable Systems and Software Research Group, which I was a part of. And he currently focuses on blockchain systems and education. On a personal note, Professor Korth is one of the most intelligent and humble people that I know. And he has an endless list of puns, all sorts of jokes that never gets old. I know that I would not be where I am today without his help. And it is my honor and privilege to introduce him to you all. So thank you for being here, Professor Korth. The floor is yours.
Hey, Judy, thank you for all that. That's quite the introduction there. So I had put together a who am I slide. Where am I? You got that already. Let me just roll on here. So what I want to talk to you all about today is looking ahead. I mean, every
Screen about.
pardon me?
We're not seeing your screen. I can't see your screen.
Okay. Oh, I did a share, and it seems to have gone away. Okay, let me see what's happening here.
Sounds good.
I see what happened. Google security didn't want to authorize it, and
It's there?
earlier on fire. Oh no, not yet.
Choose. Still not getting it?
No, I'm not seeing it. But if you need, I can always pull up the slides as well.
Hey, you've got the slides, so we can do that while I try to.
Yeah. I'll work on pulling that up.
Stupid, security things.
Yeah, I'll pull those up in the meantime while you try and work through that, just in case.
Okay, I'm gonna give this one more shot here while you're doing that. We'll see who wins.
All right. About to get back to it.
I'm not ready to go.
But first,
Okay, why don't you just go with that, and I will blast my thing out of here. So you're gonna share the screen and show the slides? I don't see
Yep.
it yet. Okay, no, almost.
See my screen before.
I'm
Okay.
seeing everything. All your secrets are up there. And that's kind of overlay oddly enough. Pop ahead a couple. Yeah, we got that. Yes, go on to the next one. Okay, you went ahead two. Back up one. Okay, we got it. Good. Thanks for hanging in there. So I guess I'm between the shots and pints and happy hour. So that should be fun. So what I wanted to talk about today is something that's actually been in every talk. We're hiring. So from where are you going to hire? And obviously universities are one of the hunting grounds. But the question there is, what should we do? What are we doing? And what are we trying to teach? Well, I mean, obviously, looking at this crowd here, it's developers, researchers, but I would contend that another important role for universities is blockchain education for all those other folks I list up there. All it takes is a quick look at some of the strange policies coming out of DC to realize that we really need people in government, in enterprise, even broadly among citizenship, who are truly literate on blockchain. But if you look at the developers that are really making a difference these days in blockchain, some of them have gotten there not bothering with the university education, which leads me to my next slide, which is one possible view here, is one going back to an album I first listened to when I was about Jimmy's age, actually probably still just a tad bit old. And that is, do we really need education at all? And so, moving on from that then, I can ask the question, so what place does
So now-
university really have in blockchain?
I can just take notes all day
Do we
long
really provide the value that we need to for what we charge?
and then just delete them.
Yeah, we charge more than a Bitcoin a year for a residential university. Not cheap. And so, next
Let's
slide,
see.
please.
We want
What I'd like to do in this is not just tell you, what I'm doing here at Lehigh, what we think we might be doing in the future, but to make this a two-way discussion, a chance for me to hear a bit also about what you all think ought to be done in this space. And so, what we're doing today is far from the final answer. And my email address, it's on the title slide. I listed it again. Really love to hear from you, not just in the questions, but also offline afterwards. And so if we go to the next slide, Jimmy. Before I talk about these specifics, the issue of what to teach is it's a long story in computer science, and a constant battle between the folks focused on that first so many different things over the years. And then there's the fundamental traditional type folks who say, no, you should be teaching basic Wasm concepts. Of course, the answer is you need a mix of those. But what's the right mix? What's the collection of concepts, facts, versus experience doing things? And then doing what? You see lots of computer science where you see students doing coding, but more just for the sake of doing coding as opposed to really learning how to code, how to develop, how to think. And so we need to find this right balance between the immediate and practical and the basis for a career. And in all that, I mean, listen to lots of folks talking about education, and they forget that it's got to be fun. If you're going to be in a career for some 40, 50 years, and believe me, I know about that, you really need to enjoy it. And so, showing the fun of doing all this stuff, and certainly on blockchain, and I can't think of a more fun thing to be in, and that's got to be conveyed in any kind of reasonable education. And so, next slide, please. What is blockchain? And if I talk to some of my colleagues, here in computer science, they go, well, no, it's just one more thing in computer science. But it's a lot more than that. Among all the various applications of computer science, blockchain's unique in its immediate impact on other disciplines. Listen to the talks we heard today, and we hear elsewhere in blockchain. Finance is always there in so many different ways. Certainly DeFi, central bank digital currencies, and then beyond the finance, things very quickly get to issues of privacy and governance, the whole idea of decentralization. And these are things that go beyond computer science concepts, yet they are immediate and fundamental things in blockchain. And we really then need to train not just computer scientists to do blockchains, but train these finance professionals, policymakers, politicians, yes, even lawyers and journalists, so they avoid making some of the bad policies we see coming down the road. And so, next please, there's some real challenges in trying to communicate blockchain technology to students. And one of the biggest challenges that it's not just teaching about computing systems, consensus, crypto, etc. But almost any public blockchain has embedded in it an economic ecosystem. The incentives, how people behave, believing that incentives cause people to do the right thing, but then having further punishments when they don't. This is the domain of economics class. And even there, the students who take a couple of courses in economics, they take macro and micro, what they really need probably is game theory. And that's considered a more advanced course. So we face this problem that to teach a blockchain course, we really have to bring in a whole pile of disciplines that we don't teach very well in the university. I mean, even math. When we make everybody go through 3 calculus courses. Well, I start off with crypto, group theory, discrete mathematics, things that we don't teach. Actually, discrete math we don't teach in our discrete math course. So it's a really challenging setting, but most definitely, as I said. So if we could move ahead once again. What I'm going to be doing here is to start off by taking a stab at what we're doing. Not that this is the right thing, the definitive thing. In many ways, it's just the result of an evolution of several years of putting together a larger and larger blockchain program. But what we've got are a bunch of courses, and I'll talk a little bit about each one, because I certainly want to get some feedback on what's in those. But then another aspect of what we do is something I think is very important to that more practical side of education, is Capstone Projects. So all our computer science majors, we have a whole bunch of different programs, but at the end of it, And typically these are done with outside business partners where they're trying to solve a computer science problem in that enterprise. And we put together a bunch of those in the blockchain space. Jimmy's one of those students who did one of those. And so that's one way of getting some nice real-world training in blockchain. Another is various research projects and independent study projects. And I saw before I started talking here that one of my current master's students and also Chain Safe intern, Maxime, he's on here. Hi, Maxime. And then another thing we have is a whole bunch of interdisciplinary collaboration. So outreach beyond the computer science, kind of tech side of blockchain to folks particularly in the business side of Lehigh. And so with that, let me move ahead and say a few words about the things we're doing. So in courses, we've got 3 courses now. Okay, so I listed our course numbers, you don't care about that, but the content. So that first one, CSE 242, is unapologetically computer science, an elective for computer science majors. There is nothing on applications, nothing on policy. It's crypto math, so it's cryptography from Caesar cipher to Diffie-Hellman, all packed into a fast-paced several lectures. Then cryptographic data structures, Merkle tree and frames. Then a lot of time on consensus. I mean, obviously proof of stake, proof of work, but also a review of the various approaches to message-based consensus. We start with the classic BFT going back to the paper by Lamport, then PBFT, Nancy Lynch's stuff, but then a survey of a number of cryptos chosen not because they're hyped, not because of their market cap, because they have something interesting in the way they manage consensus. And so after having obviously covered, Bitcoin and Ethereum, I'm going to talk about Polkadot, Algorand, Mina, Solana, Stellar, I got the Stellar cap here, and a few others. Each case chosen not to cover all the details, but here's the key consensus tool. The idea being, if you're building a new blockchain de novo, how are you going to do consensus? You can copy something else, or you can look at the key techniques, the key algorithms, and the goals of showing that how do you show a consensus system is correct. So we talk about the formal foundations that come out of the distributed computing community, proofs of safety and liveness, and tie all of that in. And then of course there's coding, and there's a project writing smart contract and Solidity, and we have our own private proof of authority node for that, so we don't have to tangle with testnet, and I can give them as much ETH as they want. We have students who love showing MetaMask and showing they have 1,000 ETH and making my friends think they're rich. But some have joked about trying to sell our private LU, and I sure hope they won't do that. I'll be in trouble. But that's the CS course. Then the next one, CSB, that's in computer science and business, 242. That's a course that has sort of just the minimum tech, body honest. And then after that, we talk about various applications, policy, and I bring in various outsiders, have a fun group of outsiders come in to talk. I've had the global CTO from Deloitte for blockchain. I've had folks from Citibank, Ethereum Classic Labs. Of course, I bring in my 2 students from the class of 2018 who run the Dolomite Decentralized Exchange, and we get to talk about their experience, and a whole bunch of others. We have a whole bunch of good friends and alums, and among our Lehigh alums is Kevin Wirth, CEO of CoinDesk, pre-COVID, He actually would drive out from New York, come to our class, and it's quite fun for students to get to see him. And then another course I'm doing this one for the first time this fall. Lehigh has a Master of Science degree in financial engineering. And financial engineering had been mainly data analytics. The business dean realized that ought to be blockchain too, so I was asked to put together a course for them, and I'm doing that, taking advantage of their math background with financial system on this. You ought to know what it's about. But then a lot of time on financial applications, digital currencies, and policy issues, but a much deeper dive because these are actually finance things. And I'm quite amused teaching that course, I gotta tell you very honestly, so it's financial engineering. I was a math major with a degree in CS. I've never taken an engineering degree. I've never taken a finance course, so no engineering course, no finance course, and I'm teaching a grad course in financial engineering. Perfect. Anyway, let's go with the right side of things here. Moving away from the teaching space, comments about things we're doing in research. And we have a bunch of research projects going on here. I don't need to read them to you. They're all the acronyms and buzzwords, clearly familiar to most everyone here. But we're also working in a synergistic way with our colleagues here. So I'm part of a broader research lab that's focused on parallel and distributed computing. We go by the name Scalable Systems and Software Research Group. And working with folks there and with Maxine, who's listening now, we're looking at how to take advantage of modern computer architectures to speed up the generation of zero-knowledge proofs. You know, cool stuff and part of the synergy you can get in a university setting. In terms of synergies with business, working with a professor of finance on issues in central bank digital currency policy, and working with some students looking at something that's kind of bridging in between those things, looking at how one could architect a governance mechanism to minimize the opportunities for various MEV exploits, and if they can't be avoided totally, make it possible to detect them, you know, even after the fact, either as part of validation or in a more government-driven thing like the CBDC for regulatory purposes. And the last thing I list here on data consistency. So this one goes way back. I told you I was old when I worked in Floyd, but back in my earlier days of doing database research when I was at the University of Texas, we looked at the idea of database consistency across independently managed databases. Well, if you look at it slightly differently, think about consistency across independently managed chains, parachains, shards. Very similar issue, but some of the details, of course, are quite different. And so we're looking to bring some of our old-time database expertise into the blockchain. And then, Jimmy, if I can have the next slide, I'll say a bit about our undergraduate projects. We have lots of undergraduates doing capstone projects, have a couple of completed ones, one involving verifiable letters of reference, and some of the participants in that are on this call here. We also did a project to look to replace the on-campus currency. You may know most universities have some kind of dining dollars type thing. It's called Gold Plus Lehigh. So we did a project to replace that with a cryptocurrency. Lehigh is the mountain hawk, so we call it Hawkcoin. And we almost got it deployed. We outperformed their legacy system, but the university quickly went to their outside vendor and got a performance upgrade. And they didn't want to bring in our blockchain system and maintain it internally after the students graduated. But it was fun anyway. And looking forward to the spring term, we are lining up a whole bunch of cool blockchain projects. I haven't finalized all of them yet. January still, a month and a bit off. But we are looking to have a couple of enterprise blockchain projects with a major database vendor working with Fabric. We're looking at working with a couple of blockchain development firms with some interesting projects there, possibly one in health, and then one that's a really cool social justice theme of using the blockchain to verify that farm workers get paid. The specific one in mind here is going to be Bitcoin, and so the idea then is that various fair trade organizations can look and see, hey, yeah, the workers really got paid. And with that, then hopefully, help ensure not only that they do get paid, but then that their produce is then marketable, creating the whole, virtual cycle there to a virtuous cycle. I can say virtuous when I'm too confusing, to create a nice financial ecosystem there. And then moving ahead again, Jimmy. I missed something on the previous one. Sorry, my bad. One off there because I missed the undergrad independent projects and listed a couple that are going on now. I've got 8 students working with me in the spring on various independent projects. We're defining, a number of these are fun educational things for the students. Some are things that could certainly turn into research projects for students who stay on for a master's. And now to the next thing. So I've talked already about the fact that I'm working with folks in finance, that we've got courses there, and in the Center for Financial Services, they set up a blockchain lab, and I'm the blockchain guy, so I have to run that too. And on the business side, and trying to practice what I preach in terms of outreach, I've run a seminar series for business faculty, basically going through every discipline in our business college and letting them know that blockchain matters. Yes, it should be in your courses, and certainly should be on your radar for research. And then moving ahead once again, Jimmy, that's where we are now. As I said, this is just a stab of what to do in this space. Not the final word, looking for feedback. And the bigger question here is, are we really doing things to provide true value to students and move them into a constructive, fun career in the blockchain world, or are we just doing a brick in the wall? And so I'll go ahead and take whatever questions there might be, and thanks for hanging in there this long.
Come back on. Okay, here I am.
Okay, now I'm set up to see the Q&A myself as well. And I love this one. I see Pink Floyd sent me the question. Education is largely outdated. So how do we endeavor to keep the curriculum up? One of the things that I talk about is this trade-off between current technologies and concepts. And if you look at all my courses, there's one biggie missing, and that is a deep dive into the tools you need to use to code today in the blockchain space. And that's something we make up for with the independent projects, the capstones, and so on. And so that's the part that's current. The course stuff is more focused on the last thing. But more broadly in computer science, we have that problem big time. And we try to revise our courses, but of course you've got faculty who are focused on the research. It's a lesser priority, and it is a constant running battle. And then we have, shall we say, external enemies. Basic choice of programming language. Okay, we do Java. Please don't cringe. Why do we do Java? Well, the AP exam is in Java. And so unless we want to run 2 paths in, AP students and our own students, we're kind of constrained for making a more modern choice. So constant battle. We try. You know, Jimmy's been through it. He can tell you whether we do a good job or not a whole lot better than I can. So I'll throw the question back to Jimmy.
Gosh, it's coming back to me.
Okay, you can take the fifth on this one.
Yeah, I'll
But I can't take your degree back.
No, that's mine now. I like
Okay,
to
we
think
can look
about
backward. We'll take you off the hook there.
So yeah, we got a bunch of like, yeah. Go ahead.
Oh, good. So I'll move on down here. How do you bridge conversation concepts with individuals who don't have the prerequisite knowledge? Oh yeah, I mean, there are lots of those, and that's a big problem. It wasn't too long ago, I was listening to on Sirius XM, some business station, and somebody was asking, which is better, Bitcoin or blockchain? Like, oh, I'm ready to just drive off the road into a Merkle tree or something. It is really hard to communicate this stuff because it is so different from most people's experience. And then you have folks like Mark Cuban and Elon Musk who seem to make things worse rather than better in a whole bunch of cases. But I mean, that's something in my more business-oriented undergraduate course. It's kind of the first thing I have them do. First paper they write, explain Bitcoin to your grandmother. And just to get students to think about how do you take these ideas and relate them to everyday experience. And I've gotten some really amazing ones back, approaches I wouldn't have thought of myself. So I think my short answer to that question as a professor is listen to your students. Okay, so multidisciplinary bridges. I mentioned the bridges with finance. We've got quite a bit of that there. There's a professor in accounting I talked to who is very computing astute, and actually one of the independent study projects I'm planning to do this spring likely will involve him and looking at various issues of sort of validating and presenting business data using ZK technology, so you can hide the raw data but still have an effect in the audit. And approach to teaching changed over time. Well, we don't actually have a formal course in Web3. I mean, that's the stuff that gets taught hands-on in the capstone courses or in independent projects. So we're not actually teaching that. We have a web apps course. The web apps course is very Web 2, for better or for worse, but tools you definitely need to move into this space. And if I can ever get in place a true hardcore developer course, that's when I'll get to address your question. But I do love the question. And MOOCs would be a wonderful thing. I mean, we obviously have a lot of video in the bank now, thanks to COVID. And I've been trying to run more of my classes with classroom styles, recordings of lecture or the assignment, and then we can just discuss in class. Now, going the MOOC route, love to do it, but I have to get the university to be willing to invest in professional production. As I've learned during COVID, being the presenter, the producer, and the guy watching the chat going on the side, especially when you have something like the Uniswap Air Drop happening in the middle of class, as some people will remember, makes for an experience. I expected a commission, I never got it. Doing something that's truly MOOC-like and professional is a next step, and I'd really like to sell my university on doing this. Chuck E. Cheese as a way to I love this one. Is using a Chuck E. Cheese coins, tickets, prizes a good way to explain ERC-20 versus ERC-721 to all the students? That is phenomenal. I that's something that is a broader thing, just in terms of high school students going to college, and if they don't, I don't get to see them here. What when I was running our Lehigh Unique Computer Science and Business program, which is a single degree, dually accredited called CS Business, worked a lot with admissions. Yeah, we got a graduate there, and so I got to high school students who at least go to a college info section are already with one foot in the door. But I really tried to sell the value add, and I think the value add is really the broad immersion we get. Not just so much necessarily even in courses, but from your fellow students. That you hang out with students, majoring in so many different things, thinking about things in different ways, that I really view the 4 years in college as learning to think, and with some focus. And a hard thing to do, and some universities are trying to go in many ways in an opposite direction there. And that comes back again to this whole idea of blockchain and its connectedness with the real world. In these policy and application-oriented classes, I deal with students with a broad range of political viewpoints. Students just off the plane from China who love DSEC, the Chinese digital currency, and students who are very much hardcore libertarian. And I need to challenge them both and try not to reveal my views, because that's not my job as an instructor. Yeah, some of my students probably know what I think about things, but that's for another time and place. And how do I work with finance people? The short answer, very careful. Yes, token economics, probably, I think, case in point here with a colleague of mine in finance, Kathleen Hanley, we've been putting together a real proposed policy paper on digital currency. We were working with a group trying to put together things for the then new administration. They didn't speed us up, they slowed us down, but we've really got a good give and take going on there. Now, on the other hand, when she came to guest lecture in my class, I said, well, in the last class, all of the students created their own ERC20 token. She was ready to pull out her cell phone and call her former colleagues in the SEC and put us all in striped pajamas until I added on the testing. So, yeah, I mean, once you establish a good rapport and then realize I'm not really an anarchist, I actually understand what I'm doing, and they also understand that the blockchain world is coming into their world, whether they like it or not, and might be a whole lot better if they understand it. Then we can start to explain things that are going on and to realize that when we talk about a blockchain-based digital currency, well, there are other digital currencies out there. They're not on a blockchain, but airline miles. That's a digital currency. It's private, and so there's a continuum of choices, and you can create a degree of comfort in that. And okay, the whole idea of anonymity, money laundering, and so forth. Yes, I mean, that's another thing. Are we just simply promoting money laundering here? And we certainly talk about the fact that Bitcoin isn't really anonymous. You can, with a little bit of work, figure out who's probably behind a whole bunch of the various IDs, and point out that the best way to money launder is the U.S. dollar. We're not talking about banning that, as far as I know. And so we really need to think here about the broader infrastructure of finance, appropriate regulation, not over-regulation, and that this could actually be a more effective means to do that. And I've had lots of debates with students on those kinds of things. And Judy, did I miss any of the questions rolling through here?
No, I think you got them all, and I can't think of a better place to end it. Great job. I love that you went to town on the questions. Easy. Oh, I think it's fine. there's another one that popped up.
Oh, is
Okay.
there? Ah, here we
Yep.
go.
What are your top 3 real-life applications in blockchain?
Oh.
Verifiable reference letters, right?
Oh yeah, obviously Jimmy's project in Bitcoin. I mean, obviously, real life application of blockchain. I gotta go with Corey and Adams, decentralized exchange fellowship. Real proud of those 2 students. They were